Magandang buhay! Welcome to your mathematics class. I am teacher Rosie, and today we will learn how to add, subtract, multiply, and divide radical expressions. Are you ready? Let's start! Our objective is to perform operations on radical expressions. Let's first have addition and subtraction of radical expressions. Radicals can be added or subtracted if they are similar or like radicals. Similar or like radicals are radicals whose index and radicands are the same. Here are some examples of similar radicals. 7 square root of 5, 3 square root of 5, and negative 2 square root of 5. Another example, we have negative 9 cube root of 2, 4 cube root of 2, and 6 cube root of 2. While here are examples of dissimilar radicals. Square root of 5, cube root of 5, and fourth root of 5. As you can see, they may have the same radicands, but they do not have the same index. Another example of dissimilar radicals, we have cube root of 4, cube root of 3x, and cube root of 2. As you can see, they may have the same index, but they do not have the same radicands. So they fall under dissimilar radicals. Similar radical expressions can be added or subtracted the same way that monomials are added or subtracted. Say for example, we have 3x plus 2x, the sum is 5x. Say we have 8y minus 5y, the difference is 3y. Or subtracting radicals, we follow the same way with that of monomials. Let's say we have 3 square root of 2 plus 2 square root of 2. First, we add the coefficients 3 and 2. 3 plus 2 is equal to 5. Then, affix their common radical, which is square root of 2. Therefore, the sum is 5 square root of 2. Another example is 8 cube root of 5 minus 2 cube root of 5. Subtract the coefficients. 8 minus 2, we get 6. Then, affix the common radical, which is cube root of 5. Therefore, the difference is 6 cube root of 5. Let's have some examples. Simplify 3 square root of 5 plus 6 square root of 5 minus 2 square root of 5. First, taking the coefficients, we have 3 plus 6 minus 2. 3 plus 6 minus 2 is equal to 7. Then, affix the common radical, which is square root of 5. Therefore, the final answer is 7 square root of 5. Another example. Simplify 6 square root of 11 plus 2 square root of 11 minus 3 square root of 11. Taking the coefficients, we have 6 plus 2 minus 3. 6 plus 2 minus 3 is equal to 5. Then, affix the common radical, which is square root of 11. Therefore, our answer is 5 square root of 11. Example number 3. Simplify square root of 3 plus 2 square root of 7 minus 4 square root of 7 plus 5 square root of 3. First, let us rearrange the order of terms in such a way that similar radicals are beside each other. Taking the coefficients of the first two terms, we have 1 plus 5 square root of 3 plus, taking the coefficients of the third and fourth term, we have 2 minus 4 and then square root of 7. So we have 1 plus 5, 6 square root of 3 plus 2 minus 4 is negative 2. So we have negative 2 square root of 7. Simplify, we have 6 square root of 3 minus 2 square root of 7. This expression cannot be simplified further because the radicals are not similar. There are no common factors and each radicand are in simplest form. Example number 4. Simplify 7 square root of 98 plus 5 square root of 32 minus 2 square root of 15. If you will try to observe, the radicands are not yet in simplest form. What we need to do is to look for the smallest possible factors of the radicand, which is not a perfect nth power. So simplifying the given radicands, we're going to have 7 square root of 49 times 2 plus 5 square root of 16 times 2 minus 2 square root of 25 times 2. Now, applying the product property, we have 7 times quantity square root of 49 times square root of 2 plus 5 times quantity square root of 16 times square root of 2 minus 2 times quantity square root of 25 times square root of 2. Extracting the square roots of the given perfect squares, 49, 16, and 25, we have 7 times 7 square root of 2 plus 5 times 4 square root of 2 minus 2 times 5 square root of 2. Simplifying each coefficient, we have 49 square root of 2 plus 20 square root of 2 minus 10 square root of 2. If you will try to observe, the three terms are now similar radicals. Now, taking the coefficients, we have 49 plus 20 minus 10. That will give us 59. Then, affixing their common radical, which is square root of 2, for our final answer, we have 59 square root of 2. Let's now proceed to multiplication of radical expressions. To simplify expressions involving products of radical, you can use this property. If A and B are real numbers and A is greater than or equal to 0 and B is greater than or equal to 0, then the nth root of A times the nth root of B is equal to the nth root of the product of A and B. So in general, the product of the nth root of two or more real numbers is the nth root of the product of the numbers. Example number 1. Multiply and simplify square root of 7 times square root of 5. We have the square root of 7 times 5. Therefore, the product is square root of 35. Example number 2. Find the product of 2 square root of 2 and 3 square root of 8. First, we multiply both the coefficients and then both the radicands. So 2 times 3, we have 6. We have the radicands 2 times 8, 16. Therefore, we have square root of 16. Now, extracting the square root of 16, we have 4. So 6 times 4, the answer is 24. Example number 3. Multiply and simplify 12 square root of 3a times 4 square root of 4b. So we multiply first both the coefficients, so we have 12 times 4, and then multiply both the radicands. So we have the square root of 3a times 4b. 48 times the square root of 4 times 3ab. Extracting the square root of 4, we have 48 times 2 square root of 3ab. 48 times 2 is 96. Bring down the square root of 3ab. Therefore, for our product, we have 96 square root of 3ab. Example number 4. Multiply and simplify 8 square root of 10m times 5 square root of 2m. Again, multiplying both the coefficients, we have 8 times 5, and then multiplying both the radicands, we have square root of 10m times 2m. Simplifying, we have 40 square root of 20m squared. Simplify the radicand 20m squared, we have 40 square root of 4m squared times 5. Extracting the square root of 4m squared, we have 40 times 2m times square root of 5. 40 times 2m is equal to 80m. Bring down square root of 5, therefore for our product, we have 80m square root of 5. Example number 5. Multiply and simplify cube root of 9y squared times cube root of 3x to the 6th power y to the 4th power. Multiply both the radicands, we have cube root of 9y squared times 3x to the 6th power y raised to the 4th power. Therefore, we have the cube root of 27x raised to the 6th power y to the 6th power. Now extracting the cube root of the given radicand, we have 3x squared y squared for our final answer, since all the radicands are perfect cubes. Let's now proceed to division of radical expressions. If a and b are real numbers and a is greater than or equal to 0 and b is greater than or equal to 0, then the nth root of a over the nth root of b is equal to the nth root of a over b, where b is not equal to 0. Dividing radicals of the same index. Example number 1. Divide square root of 10 divided by square root of 5 and simplify the result. So for our solution, we have square root of 10 over square root of 5. Simplifying, we have the square root of 10 over 5. 10 over 5 is equal to 2, so we have square root of 2. Another example, divide square root of 24 divided by square root of 6 and simplify. So for our solution, we have square root of 24 over square root of 6. It becomes square root of 24 over 6. Now the radicand 24 divided by 6 is equal to 4, so we have square root of 4. Now extracting the square root of 4, we have 2. Example number 3. Divide square root of 8 divided by square root of 6 and simplify. For our solution, we have square root of 8 over square root of 6. That is also equal to the square root of 8 over 6. If you will try to observe, the radicand 8 is not divisible by 6. So what we do is we rationalize the denominator. We now have the square root of 8 over 6 times 6 over 6. So we get the square root of 8 times 6, 48, 6 times 6, 36. So we have the square root of 48 over 36. Now, we simplify the given radicand. So we have square root of 16 times 3 and then extract the square root of square root of 36 is equal to 6. Simplifying, we have 4 over 6 square root of 3. And then, reducing the fraction to lowest term, we get 2/3 times the square root of 3. This is also the same as 2 square root of 3 over 3. Dividing radicals with different indices. To divide radicals with different indices, change the radical to the same order or index. Say for example, we have to find the quotient of the cube root of 4 divided by the sixth root of 2. The first thing that we need to do is to change the divisor and the dividend to its fractional exponent. So we have 4 raised to 1/3 divided by 2 raised to 1 over 6. Next, make the fractional exponent similar. So we have 4 raised to 2 over 6 divided by 2 raised to 1 over 6. Now, write each of them in radical form. So we have the sixth root of 4 raised to the second power divided by the sixth root of 2. Simplifying, we have the sixth root of 16 divided by the sixth root of 2. Dividing the radicands, 16 divided by 2, we get 8. So we now have the sixth root of 8. Next, write the radicand in exponential form to reduce the index. So we have the sixth root of 2 raised to the third power. Then, write the given in exponential form. So we have 2 raised to 3 over 6, and reducing the exponent to lowest term, we have 2 raised to 1/2. And lastly, change it to radical form. Therefore, for our quotient, we have the square root of 2. Rationalizing binomial denominators. Two binomial radical expressions are said to be conjugate if they differ only in sign that connects the binomials. Say for example, we have the radical expression 5 minus square root of 2. Its conjugate is 5 plus square root of 2. Another example, square root of 2 plus square root of 7. Its conjugate is square root of 2 minus square root of 7. Now, if a fraction contains a binomial radical denominator, you can rationalize it by multiplying it by its conjugate. Say for example, we have rationalized 2 over 3 minus square root of 3. So for our solution, we will rationalize it by multiplying both the numerator and denominator by the conjugate of the denominator 3 minus square root of 3. The conjugate of 3 minus square root of 3 is 3 plus square root of 3. Multiplying using distributive property, we get 6 plus 2 square root of 3 over 9 minus 3. Simplifying the denominator, we have 6 plus 2 square root of 3 over 6. Simplifying our answer, we have 1 plus square root of 3 over 3. For your assessment, perform the indicated operation or operations and express your answer in simplest form. I hope you learned something today. Before we end, let me share what Archimedes, a famous mathematician, once said.
Mathematics reveals its secrets only to those who approach it with pure love for its own good. God bless you.